Hello, ladies and gentlemen. This is Energy Training. In this lesson, we're going to have a look at the series and parallel connection of lithium batteries. Before you parallel or series or combo your batteries, making them into the battery bank, please make sure two things. First, the batteries will be integrated into the battery bank must be exactly the same. And also, it is better to make sure their production date is within the range of 1 year. So no combination of old battery and young battery, and also no combination of different batteries. You can see from here, exactly the same. Then you need to make sure the SOC of each battery that you're going to make them into the same battery bank are at the same SOC level. The easiest way for us to do it is to fully charge each battery individually. So you can have all the batteries at the same level, which is 100%. Then the wires. The wires should be wire-sized and should be exactly the same gauge for the positive and the negatives. And also, they need to be at the same length. You can't do that, for example, a longer wire for positive and a shorter wire for negative. That will cause imbalanced charge and discharge problem of your battery bank. And also, it harms the life of your battery cells. In this case, I'm going to demonstrate it and show how can we do it with our super slim solid-state battery. Maybe we can take a look at the specification of each of the battery. For each battery here, the nominal voltage is 12.8 volt. It means this is a 12 volt battery. And the capacity is 104 amp hour. Maximum charging current is 100 amp. Maximum discharging current is 200 amp. Now, it's finally the time for us to have a look at the connections and also how will it change the specification of our new battery bank. Thanks to its solid-state lithium battery cell, so we don't need to worry about any electrolyte leakage, which means we can mount our super slim solid-state battery in this position, and we can have a really clear picture of the terminals. First, just as I mentioned before, check the SOC level. For this battery, you can connect it to the DC home and read the SOC from an app, or make it simpler, because they are fully charged, you see? For energy batteries, as long as the open circuit voltage is higher than 13.4 volt, that means the SOC is 100%. All right, higher than 13.4, another fully charged battery. So SOC, check. Then exactly the same battery, so battery type, check. Then the wires, length and gauge, check. Okay, so let's do the parallel first. For parallel, we need to connect the same polarities together. And when you're doing it, please pay attention to the end of your wires. Do not short circuit your battery. Usually, we get started from the negative. So now the battery has been connected in parallel. Which one is the positive terminal of this battery bank? It could be this, it could be this. It depends on you. If you choose this one as the positive of your battery bank, so this one must be the negative. You can't choose the two terminals, positive and negative, from the same battery. If you choose this as the positive of your battery bank, so this will be your negative of your battery bank. Then let's have a look at the specifications of this battery bank. Since they are paralleled, so everything regarding voltage will never change, which means this battery bank is still 12.8 volt. Maybe we can have a look. Positive, negative. Then accepted voltage, everything regarding ampere, will be doubled because there are two batteries parallel. So now this battery has been changed into a 208 amp hour battery. Then maximum charging current. It is also regarding the current, which means for this battery, it is also doubled. So does the maximum discharging current.
Next part, let's do series connection. That means the first one battery's negative terminal is connected to the other one's battery's positive terminal. So this terminal becomes the new positive terminal. This terminal becomes the new negative terminal. Let's say the new battery bank's voltage. As you can see, all the voltage will double and all the currents will stay the same. This figure will double becomes 25.6 volts. These three will stay the same. That's all. Thanks for listening.